Hey, Michael Matthew Chase, welcome to class on Thursday the 25th. If you'll look at your notes on page 73 and 74, you should have 2 pages you've printed. If not, please stop and print those. And let's jump right into page 73. Matthew and Chase, you both owe me a quiz and a test by Monday. They're due Monday, so if you don't turn them in, you will lose points. I've emailed your parents. They both know this. Please make sure that you have those tests and quizzes ready to turn in Monday. If you need help or questions, call me before class on Monday or email me. Okay, moving on. If you look at the top of page 73, you see 2 ordered pairs. They're here on the screen in front of you. You have a choice. I want you to write an exponential function on your own. That's what we did in class yesterday. You can do that by pausing the video, doing it on your own, and if you get it right, you get a bonus point, half a bonus point, or you can just watch me do the problem. So that's up to you. So go ahead and pause the video, work it on your own, or you can just watch me do it and not take the half a bonus point. Okay? All right, here we go. Let's go ahead and write the exponential function using these 2 ordered pairs. Here's the model that you learned to use yesterday. There's the model. So let's come over here. Step 1 is to take an ordered pair and substitute it into your model. So I'm going to take our first ordered pair and substitute in those 2 values for x and y. Now, the next step is to solve both sides for a. So I'm going to divide by b to the negative third, divide the other side by b to the negative third. These cancel right here, and now I'm left with 3 over b to the negative third equals a. Now that's fine. A's all by itself, but you know what? See this right here? I can make this a lot simpler. I can take this b to the negative third and bring it up top and change the exponent so it's 3b to the positive third, and boy, students, that sure does make it a lot easier. Now if you didn't do that, you can still get it right, but that makes it a lot easier. I'm going to do that. Now step 2 says to take your other ordered pair and substitute your other ordered pair in like this, and then we go ahead and also substitute this in for a. So 3b cubed equals a, so where a is right here, I'm going to go ahead and substitute for a right here. I'm going to put 3b cubed for a, bring down my b to the 4th, and bring down my 6,561. Now let's solve for b. Let's solve for b. So on the right side I can do a little simplifying. I have 3b cubed times b to the 4th. That's 3b to the 7th. Now to get b by itself, you divide both sides by 3. Divide the right side by 3 and you're left with b to the 7th. Divide this side by 3 and you get 2187. And now you want to take the 7th root of both sides because you have b to the 7th. Now, if you need to use your calculator, remember you type 7 first on your screen, then you push the math button, and then go down to option 5 and click on that, and then up will pop the 7th root, okay? But if you take the 7th root of both sides, you will get 3. You will get 3. So now we know what b equals. Now the last step I told you is to take this equation right over here, your 3b cubed equals a, and where the b is, you're going to substitute 3. So we put a 3 in for b, and remember, you don't multiply these first, you do your powers first. So 3 to the 3rd power is 27, 3 times 3 times 3, and then you multiply 3 times 27, that's 81 equals a. So look at that. We know what a is, we know what b is, so here's your final answer right here. Y equals a, and a is 81, and then b, and b is 3, and your 3 is to the x power. I'm going to put a red box around the real final answer. That's your final answer. All right? So there you go. Either you followed along or you tried it on your own. I hope you got the half a bonus point if you tried it on your own. All right, let me quickly grab a drink of water, and we're going to go ahead and jump right on. Didn't mean to do that. We're going to go ahead and jump right on to your notes. So please look over in the middle of page 73, and I'm going to kind of read these to you as you follow along. Okay. Please look in the middle of page 73. We're going to write power functions today. Now, yesterday we wrote exponential functions. Today we're going to write power functions. Now, I'm going to read and you follow along. Yesterday we looked at writing exponential functions. I'm just reading your notes. Just follow along. The model we used was y equals ab to the x power. Today we'll be looking at writing power functions. The model we will be using is y equals ax to the b. Do you see the difference? In an exponential function, the unknown x is an exponent, and in a power function, the unknown x is a base. Now, would you please look up at the screen on your computer there, students, for a second. Here's the model we used yesterday. This is the model for writing exponential functions. Today, we're going to use this model to write power functions. Do you see the difference? Over here, the x is up high as an exponent. Over here, I'm going to go ahead and put EF for exponential function and PF for power function. For a power function, though, notice the x is down here as a base. All right. Now, you might not understand everything I'm going to say, but at least you can memorize this. Exponential functions have the x up high. Power functions have the x down low. Here, the exponent is always changing. You could put a 1 in for x or a 2 or a 3, and your exponent changes depending on what you put in for x. Over here, your base is always changing. You might put a 1 in for x or a 2 or a 3, and then your base is changing. And that's the difference between an exponential function and a power function. Now, I'm going to go ahead and read your notes. Would you look at the very last paragraph from the bottom of page 73? Now, the steps, believe it or not, are identical as the steps for writing exponential functions. The exact same steps we used yesterday. So I have just copied and pasted the steps from yesterday's notes, sorry about that, students, onto the next page. So please turn over to page 74. I'm not going to read these 5 steps. I guess I'll read them real quick, and then we're going to do 3 problems and we're done. So I love these short videos. I think they're a lot better than sitting for a couple hours. But step 1 says, substitute one ordered pair into your model, solve for A. Step 2, substitute the second ordered pair into your model, then take your equation from step 1 and substitute this into your model. Step 3, take your equation from step 2, solve it for B. Step 4, take your B value, substitute it back into your model from step 1, solve for A, then write your power function. Now that's the exact same steps we used yesterday. So without any further hesitation, let's jump into this. Please take some really good notes. Let's take these first 2 ordered pairs and let's write the power function of the graph that passes through these 2 points. Now we're going to use this model right here, y equals a x to the b, and step 1 says take one of your ordered pairs, we'll use 2, 5, and substitute it into the equation. So where the y is, I put a 5. Where the x is, I'm going to put a 2. And then step 1 says to solve for a. So if I'm going to solve for a, I'm going to divide this side by 2 to the b power, and I'm going to divide this side by 2 to the b power. These cancel out, and I'm left with 5 over 2 to the b power equals a. Do you see how I did that? I divided by 2 to the b power to get a by itself, and there, we're good. Now I'm going to circle. It's not my answer, but I'm going to come back to that and use that later. Now step 2 says take your other ordered pair and substitute it in. So here's my x, here's my y. So for y I substitute 9. The next is a. I'm going to go ahead and pause and put my a in right now. Do you see next is a? But remember what a is. A is 5 over 2 to the b. Now Mr. Erhart, where did you get that? Well, I got it from right down here. Remember, a equals 5 over 2 to the b. Now next in your model is x, so I'm going to go ahead and put an x in, which is 6. And then 6 to the what power? 6 to the b power. All right. Now we would like to solve this. This is a 9 right here, not an a. This is a 9. We would like to solve this for b. Okay. Now let's think this through here. The first thing I'm going to do is I'm going to go ahead and put this over 1. I'm solving for b, but I can simplify this side over here. It's going to take a little bit of work, but here we go. 9 equals, now watch carefully, 5 times 6 to the b would be 5 times 6 to the b. Please don't put 30, that would not be correct. And then 2 to the b times 1 would be 2 to the b power. Okay? Now, this is going to be really tough for you to see, and I feel your pain. This is not going to be easy, but I think once I remind you of this property, you'll remember it. And now you see why I kept drilling into your heads. These properties are so important, so important, so important. We learned that when you're dividing like bases, you subtract the exponents. But students, we also learned a long time ago that when you're dividing unlike bases with the same exponent, you divide the bases and write the exponent. Let me show you what I mean. Here's what we learned. We learned, I'm going to go ahead and put my 5, and then times. Now right here, we're not dividing like bases. One base is a 6 and one base is a 2. We're dividing unlike bases with the same exponent. What I taught you to do is go ahead and divide the bases. So 6 divided by 2 is 3. And you just bring down the base. Okay? So that is what you need to do in order to solve for b. Now look, I'm going to need some more room up here, so let's go ahead and keep taking notes here. Now we're going to solve for b. Please don't put 15b. Do not put 9 equals 15b. That is wrong. You cannot do that, okay? You have to do powers first before you multiply these, and we don't even know what the b is. So here's what we're going to do, all right? Watch carefully. Here's what we're going to do. I'm not sure why I erased that 9. We'll put it back up here. Now watch carefully. I'm solving for b. I'm going to divide this side by 5 and divide this side by 5. So now I have 9/5 equals 3 to the b. Hold it. Do you students not remember what I taught you the other day? How to solve an exponential equation like this? Remember what to do? Oh my goodness, we talked about this. Remember, you take the logarithm of both sides. So you put a log here and you put a log here. Remember this? And then what is your base right here? The base of your unknown. This is a b, not a 6. The base of your unknown is 3, so you put a 3. Log base 3, log base 3. Then you bring down this whole side, so you bring down a 9/5. And then you bring this whole side down, so you bring down 3 to the b. Now remember why we did that? Now look, whenever a base matches a base, all of this cancels out right here, and you're left with just b. So I can go ahead and bring down my b, and b equals all of this. b equals log base 3 of 9/5. But guess what? We know how to type that into our calculator, so you might want to break out your calculator and practice. Remember, it would be, I'm going to write it here real small, it would be log of 9/5 divided by log of 3. Do you remember that? That's just called the change of base form. We've done that quite a few times, okay? So type that in your calculator, log of 9/5, be sure and close the parentheses, divided by log of 3, close the parentheses, and you should get 0.535, 0.535, okay? So I'm going to go ahead and put 0.535. Now I'm going to have to open another screen here in a second, but now you found what b is. You solved for b. So now, remember what to do? Please follow my pen, guys. Look, see this equation right here? Where the b is right here, I can substitute this. Where the b is right here, I can substitute this, and I'll know what a is. So I'm going to go ahead, and I'm going to very quickly cut and paste this. At least I'm going to try to. Hopefully I can do that. It's just not wanting to cooperate, is it? Alright, there we go. And now let's see if we can't drag this thing. Alright, there we go. Now, what I was saying is, you know what b equals. b equals 0.535. 0.535. So where the b is, 5 over 2 to the 0.535 equals a. So now it becomes a calculator problem. Okay, now be careful as you type this into your calculator, okay? It'd be 5 divided by, and then I would put a parentheses, and I would put 2 arrow 0.535, then close your parentheses. All right, so it should look like this on your screen. It should be 5, then hit divide, and then I would hit a parenthesis, and I would hit 2 arrow 5.35, close your parentheses, and that will give you 3.451. 3.451 equals a. So now you know what a is. Now you know what b is. So write your model. Your model is what? Y equals ax to the b. So y equals, where the a is, I'll put 3.451, then put an x right here, and then for b I would put 0.535. Congratulations, we did it. There's your final answer. Let's do two more of these a little faster, and hopefully you'll get the hang of this, okay? All right, let's try the next one. 3 comma 27, I believe is what your notes say. 3 comma 27, and then 9 comma 243. All right, let's go ahead and write a power function, all right? This is my x, this is my y. So step 1, we're going to take our model, which is y equals ax to the b, and we're going to substitute this ordered pair in, and we're going to solve for a. So where y is, I substitute 27, and where x is, I substitute 3 to the b power, and I want to solve for a. So I divide by 3 to the b power, and I divide by 3 to the b power. Okay, these cancel out, and I'm left with 27 over 3 to the b power equals a. Okay? All right. Now, please don't divide 27 and 3. You cannot do that. Okay? But leave it just like this. Okay? Now, let's go ahead and let's do step 2, which is take your other ordered pair, your x and your y, and substitute those in. And by the way, when I substitute my x and y's in, I'm going to go ahead and substitute my a in also. Do you see what a equals? A equals 27 over 3 to the b power. So where my model is y equals ax to the b, so where y is, I'm going to substitute 243. Where the a is, I'm going to substitute 27 over 3 to the b power. And then where x is, I'm going to substitute 9. And then, of course, that's 9 to the b power. Now we're going to solve this for b, so we got a lot of work to do, okay? First of all, I would put this over 1, and I would multiply these two fractions together. So 243 equals 27 times 9 to the b power. And then over here we have 3 to the b power times 1, so 3 to the b power. Now, what have I taught you, students? We're not dividing like bases, but we are dividing unlike bases that have the same exponent. So what I've taught you to do is when you're dividing, bring down my 27 here, times, when you're dividing unlike bases, a 3 and a 9 that have the like exponent, you go ahead and divide the bases. 9 divided by 3 is 3, and you write the like exponent. And now we're ready to solve for b. Remember, you're solving an exponential equation now. So the first thing you want to do is divide both sides by 27. Okay? So I'm going to do that right up here. We're going to divide both sides by 27. So we have 243 over 27 equals 3 to the b. Do you see what I did? I divided this side by 27. Those canceled. And I divided this side by 27. All right? Now, look, I have an unknown for my exponent, so we're going to have to solve this by using logarithms. So I take a log of one side, we learned this the other day, and I take a log of the other side. Now, what is the base of your unknown? Here's your unknown, here's your base, the 3. So I take a 3 here and a 3 here. Now bring down this whole side, so I bring down 243 over 27, and then bring down this whole right side over here, which is 3 to the b. Okay? Now, remember why we did this. Over here on the right side, whenever a base matches a base, everything cancels out except the exponent. So I'm going to go ahead and bring down this b right here. And now over here, I can basically type this into my calculator, students. Look, I would have the logarithm of 243 over 27, and all of that would be over the log of 3. Now you really need to practice type that into your calculator, okay? So, clear your screens. Log of 243 divided by 27. I would definitely close your parentheses and then hit divide, okay? And then log of 3, log of 3. And I am getting, for that, 2. I'm getting out 2. So b equals 2, okay? There we go. Now come way over yonder. Do you see this right here, students? Look, my pen's all over it. Where the b is, you can put what? We'll come back over here. What does b equal? A 2. So where that b is, put a 2. So I now have 27 over 3 to the second power equals a. Well, what is 3 times 3? Isn't that 9? You really have 27 over 9, or 27 divided by 9. That's 3. So a equals 3. So you know what a is, you know what b is. Here's your model right up here. I'm going to go and switch over to red ink so we know where the answer is. So write your answer. Your answer is y equals, and then a is 3, and then x to the b power, and b is squared. There's your answer. You did it. One more and we're done with these notes. And then you can work on homework. There's 5 of them. It'll take you a little bit of time, probably about 30 minutes or so. And you can watch the video or you can try them on your own, whatever you prefer to do. All right? Okay, last one. I did throw some fractions at you, but it's not going to kill you. 2, 2.5. You know what I'm going to put? I'm putting 5 over 2, and I'm telling you that'd be a very wise thing to do. I'm telling you I would really do that. And then 4, 3, 6. Okay? All right, let's go ahead and get started. Let's write a power function of the graph that passes through these 2 points. So here we go. Your model is y equals ax to the b. And so where the y is, I'm going to substitute 5/2. And where the a is, I'm going to leave that a. Where the x is, I'm going to substitute 2 to the b power. Now we're going to solve for a, so we better divide both sides by 2 to the b power. And these will cancel. And I'm left with this really weird fraction, 5 over 2 all over 2 to the b equals a. Now I want to tell you something right now. This is not going to cut it, okay? This is not going to work. That's not simplified far enough. So I'm going to go ahead and slip on to another page. I want you to take some side notes here and just kind of watch what to do. It's very important you know how to do this, okay? So, all right, here we go. Now, we need to simplify this whole thing right here, okay? Well, we really have what? We really have 5/2 divided by, because that's what that big fraction bar means, 5/2 divided by what? 2 to the b over 1. Well, you know when you're dividing fractions, it's really 5 over 2 times, and then you flip the fraction, 1 over 2 to the b. So 5 times 1 is 5. Oh, students, please don't put 4b. Do not put 4b. You cannot multiply 2 times 2 until you do your exponent first. And you don't know what your exponent is, so you're going to have to write 2 times 2 to the b. So that is what a equals, okay? So this doesn't cut it. There's no way you want to use something with a fraction within a fraction. So we wrote this 5/2 divided by the bottom. Then we flipped it, and then we multiplied. Now here's what a equals, okay? So let's go back a page to where we were. So now I have 5 over 2 times 2 to the b. And all of that, of course, equals a. Let's go ahead and circle that. I'm going to go ahead and change ink for part 2. Okay, step 2 says to substitute your other ordered pair into the equation. And also, I'm going to go ahead and put a in, okay, at the same time to make this a little easier. So for y, I'm going to substitute 3/6. In fact, I don't think that's 3/6. I copied that. If you look in your notes too, this should be a 5 right here. So please fix that in your notes. All right. So y is 3/5 equals, and then for a, I'm going to go ahead and put 5 over 2 times 2 to the b. And then next is x, and x is going to be 4. And then all of that to the b power, okay, to the b power. So let's review. Where the y is, I substitute 3/5. Where the a is, here's what a equals. A equals this right here. So I substitute that in for a. And then for my x, I brought down my 4 to the b power. Okay, now let's not lose sight of the trees for the forest here. We're still trying to solve for b. So like in the previous problems, I'm going to put this over 1. I'm going to multiply these 2 fractions together. And so I would have 3/5 equals 5 times 4 to the b. Please don't put 20b. That would be incorrect. And then 2 times 2 to the b times 1. That would be 2 times 2 to the b. Now please watch what I do next. This is so cool. Just watch carefully, okay? You have learned by now that whenever you are dividing unlike bases with the same exponents, you divide the bases and bring the exponent down. So 4 divided by 2 is 2 to the b. And all of that is being multiplied by what? 5/2. Do you see that? Here's your 5/2. I just brought that down. And then 4 to the b over 2 to the b. When dividing unlike bases with same exponents, you divide the bases and bring the power down. Now, it's just like the last 2 problems. We're solving for what? We're solving for b. right? And b is an exponent. So we have learned we're going to have to take the logarithm of both sides after we isolate the base. So we're going to divide both sides by 5/2. So we divide this side by 5/2. Those cancel. Divide this side by 5/2. Now you can use a calculator here, students. You really can. Okay. 3/5 in parentheses divided by 5/2 in parentheses. All right. And you should get 6/25. Okay. 6/25 if you use your math enter and turn it into a fraction. I did that in my head. I'm going to check it real quick to make sure I'm right, but I'm pretty sure that's right. 3/5 in parentheses divided by 5/2. And let's see what we get here. I'm trying to go too fast. I made a mistake. Let's see here. Divided by 5/2. Then hit math, enter. Yes, 6/25. Okay? So, now we're not quite done. We got to still solve for b, but we should know by now what to do. Okay? Remember, when you're trying to solve for an exponent like this, you have to take the logarithm of both sides. So I'm going to put a log on one side, then an equal sign, then a log on the other side. Now, here's your unknown. What is the base of your unknown? 2. So I put a 2 here, and I put a 2 here. Now you bring down this entire side, so right here I put 6/25. And then I bring down this whole side over here, which is 2 to the b power. Now on the right side, we know whenever the base of the logarithm matches the base of the argument, everything cancels out except for the base. So I'm going to go ahead, I'm going to put b right here. And then over here, you type this into your calculator. Remember, you have the log of what? 6/25 divided by the log of what? 2. And so go ahead and type that into your calculator. I'm going to do that now myself. So log parentheses 6 divided by 25. Be sure and close your parentheses. And then divided by the logarithm of 2. And then close your parentheses. And you should get this right here for b. Negative 2.0. I'm going to round right here. 6. Okay? That's what b equals. Now, follow my pen. Watch. Way over here. See that b right there? My pen's on. I'm underlining it. See that b right there? Could I not pick up this b right here and put that in for b right there? Sorry. And then simplify that and you'll have a. Sure I can. So here we go. Watch. I'm going to put, I'm going to go ahead and circle this. There's my b. Okay. Now, right here I'm going to put 5 over 2 times 2. And that second 2 is to the negative 2.06 power. And all of that equals a. Now, do you multiply your 2's first, or do you do your powers first? Well, you should know by now you do your powers first. So with your calculator, I would type in 5, let's see, I would do this. I would go ahead and simplify your denominator. So I would take 2 arrow to the negative 2.06 power, okay? So I would take 2 to this power and then hit times 2 for this 2 right here, and you should get this right here. 0.4796. And now just simply take 5 divided by that number. So type into your calculator 5 divided by 0.4796, and I'm getting 10.42. 10.42. So I'm getting 10.42 equals a. I'm really sorry about my throat, guys. I'm just doing so much talking on these videos. I'm just not used to it, to be honest with you. All right. So now I know what a equals. Let me pause and get a drink of water here. Okay, now I know what a equals. I'm going to circle that in red. And now I know what b equals. I'm going to circle that in red. So I'm going to write my answer right up here in this big box. My answer would be y equals a. So that's 10.42. And then parentheses x. And then my b, my power, would be negative 2.06. So there you go. That's the end of the notes for the day. You now can look at your homework sheet and you can see that you have 5 homework problems to do. And you know what? I've told you guys all week, I've really tried to get tougher on you guys, making your quizzes due by a certain date, making your tests due by a certain date. But I am not going to collect your homework this week, okay? I mean, I'm telling you, you need to do it. You need to do it. It is mandatory, but I'm not going to check it, all right? So you have 5 problems. That's not much at all, okay? 5 problems to do here. And so go ahead and get started on this. Or if you want to do it later, that's up to you. I'm going to go ahead and work the 5 problems out now so you can watch me work them out. Or if you prefer, you can go ahead and do them on your own. Check your answers in the back of the book. And then the ones that you miss, you can watch the videos for those, okay? So that's your choice. And I'm going to pause the video, run and grab my book, and I'm going to work these 5 problems out for you. All right, let's work these 5 problems. I do want to apologize for my voice. I know what the problem is. Not that you care about all my personal life, but we had 4 soccer practices tonight, and then the kids doing their chores and showers. We got them to bed late. So it's past midnight now while I'm making this video, and it's just really affecting my voice. Okay, let's start off with, so I do apologize for that. Let's go ahead and start off with number 29. Number 29. Number 29 has these ordered pairs. 2, 1, 6, 5. Now I'm going to go fast, but that's because you can always back up the video, but you can't speed me up. But you can always slow me down and back the video up. Okay, let's write a power function. The model is y equals ax to the b. Step 1 is you take your first ordered pair and you substitute it in. So where the y is, I'm going to substitute a 1, and where the x is, I'm going to substitute a 2. And now we want to get a by itself, so we divide this side by 2 to the b power, and we divide this side by 2 to the b power. These cancel, and I'm left with 1 over 2 to the b power equals a. Now it was pretty insignificant. That was pretty easy. Now let's come over here, and let's go ahead and do step 2. Step 2 says you substitute your other ordered pair in, but you also substitute this in for a. So for y, I'm going to put a 5 equals, for a, I'm going to put 1 over 2 to the b. For x, I'm going to substitute 6. And then for b, that's going to stay b. All right, now we're supposed to solve this for b. So remember, we put this over 1, and we multiply these 2 fractions together to simplify the right side. So 1 times 6 to the b power is simply 6 to the b power. It's not too bad. And 2 to the b power times 1 is simply 2 to the b power. Okay, that's easy. And now what have we learned already? We did 3 of these in class. Whenever you're dividing unlike bases where the exponents are the same, you divide the bases and bring the exponent down. There. And now the base and the exponent are all by themselves, so we're ready to go ahead and take the logarithm of both sides. Now, when I take the logarithm of both sides, I'm solving for b. What is the base of my unknown? 3. So I put log base 3 and log base 3. Now bring down the whole left side, it's 5. Bring down the whole right side, that's 3 to the b power. And then we really should know what's going to happen here. Whenever a base matches a base, everything cancels out except the exponent. So I'm going to go ahead and put a b right here, b equals. And then this is a calculator problem. Remember, you would have log of 5 divided by log of 3. So if you type that into your calculator, we'll find out what b equals. Let me turn on my handy dandy machine. Log of 5 divided by log of 3. I'm getting 1.465. So b equals 1.465. That equals b. And now remember how to solve for a? You just come over here, look students, and where the b is, right here, this b, you put this number in. So I'm going to have 1, let me do that, let me change colors. I'm going to have 1 over 2 to the b power, and b is 1.465 equals a. So I would go ahead and simplify your denominator. I would type in 2 to the 1.465 power, and you will get 2.761. So 2.761, and then take 1 divided by that. So here we go, divided by 1, and you will get 0.3622. 0.3622 equals A. And now let's write our model. So here it is. Y equals 0.3622 parentheses x to the b power, which is 1.465. All right. Now I'm going to very quickly, if you'll bear with me and just pause, I'm going to go ahead and mark the back of the book. I should have had this done already, and I apologize for not doing that. But I'm going to go ahead and turn to the back of the book and mark it so we can always check our answers and make sure we're not making a mistake somewhere. Let's see, so page 514, this is number 29, and it looks like we were getting 0.362. Yes, that is correct, okay? And I'll go ahead and mark my book from now on so I won't have to take so much time to do that. Okay, moving on, we have 4 problems left in your homework. Let's take a look at number 31. Number 31. All right, the 2 ordered pairs are 5, 12, and 7 and 25. So 5, 12, and 7 and 25. All right, so there's your 2 ordered pairs. Let's go ahead and write our power function. Our model, of course, is y equals ax to the b. So where the y is, I'm going to substitute 12. Where the x is, I'm going to substitute 5. And then I'm going to solve for a. So I divide one side by 5 to the b power. I divide the other side by 5 to the b power. And I'm left with a equals 12 over 5 to the b power. Good. Step 1, I've solved an equation for a. Now step 2 says to substitute your other ordered pair in plus substitute in your a equation over here too. So where y is, I'm going to put a 25, and then for a, I'm going to put 12 over 5 to the b power, and then for x, I'm going to put a 7 and then to the b power. All right. Now let's go ahead and solve this equation. As we've done all along, I'm going to put this 7 to the b over 1 and multiply these together. 12 times 7 to the b power would be 12. Please don't put 84 to the b power. Please don't do that. It's 12 times 7 to the b power. You cannot multiply those together because of this base. 5b to the 1 would simply be 5b. There we go. Now here's what you've learned in the past. I'm going to go ahead and bring down my 12 here, and then times. You've learned, look at my pencil here, you've learned that when you're dividing unlike bases with like exponents, you've learned to divide the bases, and bring down the exponent. So 7 divided by 5 would be 1.4, and then bring down your b. 7 divided by 5 is 1.4. All right, bring down your b. Now, we would like to solve for b, but we first have to isolate the base and the unknown. So we're going to go ahead and divide both sides by 12. We're going to divide this side by 12, and we're going to divide this side by 12. So now we have, I'm going to continue it up here. All right, now we have 25 over 12 equals 1.4 to the b. Now if you're solving an exponential like you are, your unknown is up here as an exponent. Remember, you take the log of both sides. So log of what? Log with what base? Well, the base will be 1.4 equals log with the base of 1.4. Remember, whatever the base of your unknown is, that's the base of the logarithm you use. Then bring down this whole right side, so I bring down 1.4 to the b power. Then bring down this whole left side, so 25 over 12. Now, when a base matches a base, everything cancels out, and you're left with just the exponent. So on the right side, I'm going to go ahead and put b. And then over here, this is a calculator problem. Remember, you would take the logarithm of 25 twelfths divided by the logarithm of 1.4. Now when you type, I'm getting my calculator out now, when you type in, go and get yours out and type this in, when you type in log of 25 divided by 12, you better close your parentheses and then hit divided by log of 1.4. All right, close your parentheses, you will get 2.181. So 2.181 equals b. And now students, remember, I can come all the way over here. See this b I'm circling? I can take that b, and where that b is, I can substitute 2.181. So 12 over 5 to the 2.181 equals a. All right, and that would end up being 12 over, let me go ahead and get a decimal for you. It'd be 5 to the 2.181, 33.454. So 33.454, and now take 12 and then divide it by this number here, and you should get 0.3587. So A equals 0.3587. So I'm going to go up high here, and I'm going to write my model way up here. My model is y equals 0.3587 x to the b power, which is 2.181. All right, let me pause very quickly, flip to the back of the book, and let's make sure we have that one correct. 0.358, 2.181. We are correct. Let's move on to number 33. Number 33. Let me drink of water here. All right, moving on to number 33. My ordered pairs would be 210 and 825. So there we go. Let's go ahead and write, let's go ahead and do step 1. Okay, so our power model is y equals ax to the b. So where the y is, I will substitute a 10. Where the x is, I will substitute a 2. Bring down my b. Let's divide both sides by 2 to the b power. So 10 over 2 to the b power equals a. So we're good there. Now, let's come over here, and we're going to use our other ordered pair, and we're going to substitute that ordered pair into our model, but also don't forget to substitute this in for a also. So here we go. So for y, I'm going to put 25, and for a, I'm going to put parentheses and then 10 over 2 to the b power, and then of course x would be 8, and that's to the b power. Now we're going to solve for b, so what we've done in the past is we put this over 1, we multiply these together to simplify the right side. So 10 times 8 to the b, please don't put 80b, it's 10 times 8 to the b, and then 2 to the b times 1 is simply 2 to the b power. Now, what I've taught you in the past, we've done this about 10 times already this class period, is when you're dividing unlike bases with the same exponent, you divide the bases and bring the exponent down. So I really have 10 times 4 to the b power. And where'd that 4 come from? 8 divided by 2. 8 divided by 2, bring your b down. Now, if we're going to solve for b, we have to get b and its base all by itself. So we're going to divide both sides by 10. So we're going to divide the right side by 10. That leaves us with 4 to the b power. We're going to divide this side by 10, and we get 2.5. Now, we're solving an exponential equation, so we must take the logarithm of both sides, and see your base right here of the unknown is a 4. So I'm going to put log base 4. And then leave a little space, then equals, then log base 4. Now we bring down the whole left side, so it's 2.5. We bring down the whole right side, so it's 4 to the b power. And now we've learned that when the base of a logarithm matches the base of the argument, everything cancels out except for your exponent. So we know the entire right side here is b. And then over here, this is just a calculator problem. You would want to type into your calculator log of 2.5 divided by log of 4. I'm going to do that quickly with my calculator, and we'll see what we come up with. Log of 2.5, close the parentheses. Don't forget to close the parentheses. Divided by log of 4. All right, 0.6610. You have to round the 9 to a 10, so it's going to be 0.6610 equals b. Now, look, come over here. Look at my pen. You know, right here, you know what b is. You can put a number in for b. So take this right here, and where b is, we're going to put 0.6610. So we have 10 over 2 to the 0.6610 equals a. And that would be 10 over, let's see, 2 to the 0.6610 power would be 1.5812. 1.5812 equals a. And now with your calculator, type in 10 divided by that number. So you'll get 6.3244. 6.3244 equals a. So there's your a, there's your b. I'm going to write the model right down here. The model would be y equals 6.3244 x in parentheses to the 0.6610 power. Cool. 2 left and we're done. 2 left and we're finally done. So we are very happy about that. All right. I'm very happy about that. I am very tired. All right. Number 34. Your ordered pairs would be 6, 11 and 2472. So let's go really fast. All right, we take our model and we substitute 11 in for y, and then a, and then parentheses x to the 6th power. That's not right. No, I'm getting tired. I'm getting tired. 6 to the b power. All right, now we're going to divide both sides by 6 to the b power. And you know what I never did, students? I never checked that last answer. Let me real quick go to the back of the book, because I don't want to do something that's not done correctly. 0.6352, 325, which is right, and good. Okay, all right, moving on. Sorry about that. Okay, so here we go. So we want to get a by itself, so we divide both sides by 6 to the b power, so 11 over 6 to the b power equals a. And now we come over here, and we're going to substitute this ordered pair in, so 72 goes in for y. And then this right here would go in for a. So parentheses 11 over 6 to the b. And then of course x, which is 24 to the b power. Now, I've taught you guys to put this over 1 and multiply these two fractions together. So now we have 72 equals 11 times 24 to the b power all over 6 to the b power. Now what else I've taught you is whenever you're dividing unlike bases with the same exponent, you divide those bases and bring the exponent down. So I would have 11 times, and then 24 divided by 6 is 4b, or excuse me, I apologize, getting a little tired. It would be 4 to the 24 divided by 6 is 4 to the b power. Now we're solving for b, so you want to get this part here, the base and the unknown exponent, all by itself. So we're going to divide both sides by 11. Okay? So divide both sides by 11. That's 72 over 11 equals 4 to the b power. And we're going to continue this right up here. So if we're solving for an unknown exponent b, we're going to have to take the logarithm of both sides. What's going to be log base 4, leave a little space, log base 4. Now where did I get that 4 from? Well, the base right here. Now you bring your whole left side down, so it would be 72 over 11. And then the whole right side over here would be 4 to the b power. Now, you know by now, whenever a base matches a base, you're left with just the exponent. And over here, this is a calculator problem. Log of 72 elevenths divided by the log of 4. Now remember, use parentheses. When you type in log of 72 divided by 11, then close the parentheses, and then divided by log of 4, and you will get 1.355. So 1.355 equals b. And now look at my pen. Watch my pen. There's a b right here. I know what b is. I can substitute 1.355 in for b. So I really have 11 over 6 to the 1.355 equals A, which would be the exact same thing as 11 over, let's type this in, 6 to the 1.355 power, 11.3343. So 11.3343. And so take 11 divided by that number, and you'll get 0.97. So 0.97 equals A. 0.97. So your model is going to be y equals A, which is 0.97, and then x to the b power, which is 1.355. Let me go ahead and look in the back of the book very quickly and make sure that problem is right, which I hope that it is. 7 point, what number is this? Did we do number 34 on accident? Oh my goodness, I'm so tired. We did number 34. Well, guess what? We are not going to redo, we're not going to do 35, so if you did 35, you're good. Don't worry about redoing. If you did 34, don't do 35. If you did 35, don't do 34. This is the answer to 34. Sorry, it's about getting close to 1 o'clock in the morning. I'm going to go on to number 37, and that'll be sufficient. Boy, 37 looks like a beast. Holy cow. Oh, what are they thinking? All right, well, here we go. 2.71, comma, 6.42. All I can say is we'll be using our calculators a lot on this one. And the other ordered pair is 13.55, comma, 29.79. 29.79. All right. And here we go. All right. Let's go ahead and very quickly write our model. So we would have 6.42 equals AX, which is 2.71 to the B power. Now divide both sides by 2.71 to the B power, and you have 6.42 over 2.71 to the B power equals A. So that's not too bad. Now, let's take our other ordered pair and substitute that in, plus substitute this in for A over here. So for Y, I'm going to have 29.79. That would be for Y equals this big old thing, 6.42 over 2.71 to the B power. And then X, which is 13.55, all of that to the B power. Now what I've taught you to do is go ahead and put this over 1 and multiply these two fractions together. I think we're going to need a little bit of room here for this puppy, so let's see if we can't take care of this. Much better. Okay, now what I've taught you to do is multiply these two fractions together. So 29.79 equals 6.42 times 13.55 to the B power all over 2.71 to the B power. Now, Mr. Erhart, what do we do? Just use your calculator, guys. Use your calculators until you've got calluses on your fingertips, all right? So I'm going to bring down my 6.42 and then times. Now, you know what to do when you're dividing unlike bases that have the same exponent. You divide the bases, so to simply take your calculator. Don't stress over it. 13.55 divided by 2.71 gives you 5 exactly. Cool, look at that. Gives you 5 to the B power. That's a lot nicer. Now, I'm trying to solve for B, right? So I want to get the base and the exponent all by themselves. So I'm going to divide both sides by 6.42. So I wonder if that comes out to a nice whole number 2. Probably not. 2979 divided by 6.42. No, not at all. Well, if you take 29.79 and divide it by 6.42, you get 4.640. So 4.640 equals 5 to the B power. Okay? I divided both sides. Divided this side by 6.42. Those canceled out. I divided this side by 6.42. All right, now I'm trying to solve for, let me fix the microphone there. All right, there we go. We're trying to solve for b, and so I'm going, the base here is 5, so I'm going to write log base 5, leave a little space, equals log base 5. Now bring down the whole left side, so 4.640. Bring down this whole side over here, 5 to the b power. And remember, when your base matches your base, everything's gone except the exponent. And this is a calculator problem. We have log of 4.640 divided by the log of 5. Now let's see what we get when you type that in. So log of 4.640, close the parentheses, divided by log of 5 is going to give you 0.9536. 0.9536 equals b. All right, 0.9536. And now let's take that b right there and let's do this. Let's go back here. And here's b right here. And so now we can take this b and we can substitute it right here for this b right here, and we'll get out our a. So I would have 6, it'll be really big, 6.42 over 2.71 to the 0.9536 power equals a. All right. Now, I would first of all, I would simplify the denominator, so 6.42 over something. I'm going to type in my calculator 2.71 to the 0.9536 power, and you get 2.587. 2.587. So now you want to type into your calculator 6.42 divided by 2.587, and I'm getting 2.4811. So 2.4811 equals a. Now let's go ahead and write our model right here, then I'll check it in the back of the book, and hopefully we're going to be right. Y equals a, and a is 2.4811, and then x to the b power, and b is 0.9536. Let's check in the back of the book, and hopefully, yes, woohoo, we got it right. Going to bed, guys. Hope you guys understood this, and we will have Friday's lesson, and we're done for the week.